You've been on escalators your whole life. You've seen those rows of bristles running along the base of the side panels. Most people assume they're there to clean the sides of shoes. Children drag their shoes along them. Adults use them to wipe off dirt. That assumption is wrong. And acting on it actually makes you more vulnerable, not less. The shoe cleaning belief is nearly universal. It's not just an innocent mistake. Elevator industry safety groups track this exact behavior as a documented hazard. Transit authorities in Singapore, Hong Kong, and London have posted multilingual signs to correct it. Most people walk past those signs without reading them. So what are the brushes actually for? It starts with what an escalator actually is. Most people think of an escalator as a staircase that moves. Mechanically, it's much closer to a conveyor system. Hundreds of metal steps are attached to heavy chains. Those chains run in a continuous loop, pulled by powerful motors. Each step travels at roughly half a meter per second, about the pace of a slow walk. The steps move. Everything beside them doesn't. On each side of the escalator are fixed metal walls, called skirt panels. Between every moving step and those fixed walls, there is a gap. That gap is called the step skirt gap. On a well-maintained escalator, it's typically 4 to 7 millimeters wide. That sounds tiny. But that gap runs along the full length of the escalator. Most people ride escalators every day and never think to ask what they're actually looking at. This is what we make here, the hidden design in things that look ordinary. If this one is landing for you, hit like. It tells us this is worth making more of. Subscribe, and there'll be another one ready when you are. At ankle height. For your entire ride. International safety standards set a maximum allowable gap width, precisely because engineers know what it can do. Behind that gap are chains and motors, capable of enormous, unstoppable force. The gap isn't just height. It's inescapable once something enters. Here's what happens when something enters that gap. Soft materials can deform into a space that small. The edge of a shoe sole. A shoelace. The hem of clothing. The constant sideways drag of the moving step pulls the material further inward. And the machine is far stronger than you are. Once something enters, extraction becomes impossible before the damage is done. Documented injuries include fractured foot bones, toe amputations, and in severe cases, skin stripped from the bone beneath. Children are hit hardest by this specific hazard. Most children's shoes are made of soft, flexible foam. That foam can compress into a 4 millimeter gap under the force of a moving step. A foam clog, a flexible sneaker, these can be pulled into a gap that looks far too small. Children also tend to stand sideways on escalators, and that puts one foot aimed directly at the side wall. US safety regulators issued a specific warning about this in 2008, after a documented spike in incidents. The brushes exist to prevent exactly this from happening. Their official name is skirt deflector brushes, and their function is deflection, not cleaning. The bristles project outward from the skirt panel by roughly 25 to 35 millimeters. They sit in the space between your foot and the gap. If your foot drifts too close to the side, it touches the bristles before it touches the wall. That matters for 3 reasons. First, physical standoff. Your shoe is held roughly 30 millimeters away from the actual gap. The dangerous space isn't accessible. Second, a tactile warning. The sensation of bristles against your ankle tells your foot it's too close to the edge. No sign required. No alarm. No announcement. Third, friction redirection. The bristles push your shoe inward, away from the gap, not toward it. The brush doesn't clean. It deflects. The brushes don't physically block objects from entering. They're flexible. A firm press can push through them. Their effectiveness comes from what happens before the press gets firm. Humans have an automatic response to unexpected touch. When something brushes against your ankle, your body reacts, before you've thought about it. That reflex evolved long before escalators existed. Unexpected contact was an ancient warning signal. Insects, unstable surfaces, things that could hurt you. The nervous system treats it as urgent. A beeping alarm can be ignored or drowned out. A visual warning requires you to be looking at it. A tactile signal bypasses both of those problems. It acts before attention is required. Here is something genuinely counterintuitive. Standing still on an escalator is more dangerous than walking for this specific risk. A walking passenger lifts and replants their feet repeatedly. That breaks any progressive contact with the side panel. A standing passenger keeps the same foot position for their entire ride. If that position is close to the side, the constant drag has time to act against them. The brush addresses this directly. For a standing passenger too close to the edge, the bristles keep pushing back. Not once, continuously. Now consider what happens when you press your shoe against the brushes to clean it. You move your foot toward the gap. You push against the direction the bristles are designed to resist. And you train yourself to ignore the sensation. After a few rides of doing this, the warning no longer triggers a response. The safety feature stops working because you switched it off. When something feels protective, people tend to take more risks with it, not fewer. The brush works best when you don't know what it is. It fails when you use it wrong. The first escalators appeared over 100 years ago, and none of them had these brushes. Early safety design focused on preventing falls and mechanical breakdowns. The step skirt gap wasn't yet understood as a serious injury source. Over decades, injury reports accumulated in safety databases around the world. By the early 2000s, the pattern was clear enough to force a response. Today, international safety standards require new escalators to have these brushes. But many older escalators, in older subway systems, older buildings, and much of the world, still don't have them. Every escalator you've ever ridden had those brushes. They were working the whole time. You just didn't know what they were working against. There are probably other things around you right now, small, unremarkable, doing a job no one ever explained. See you in the next one.